Hey there, welcome back. This is Aditya, and here we are going to look at the programming for data structure graph. So, graph basically is nothing but a set of vertices and a set of edges between a couple of those vertices. So, let's begin the programming for the data structure graph. To begin with, I'm going to create a class named graph, and I will initialize this graph. That is, I'll create the constructor function. The only argument will be self. So when an object is created, this function will be triggered. And what I want to do is I want to create an empty map, and I'll call that map or dictionary. I'll call that adjacency list. So let's take a moment to pause and analyze what we are actually trying to achieve. What is this adjacency list? And by the way, self dot is something just the Python notation for referring to the object. So that is something related to object-oriented programming. But let's get our focus back to the the adjacency list dictionary that we are trying to create. What is the significance? What are we trying to achieve? So this dictionary is nothing but going to contain the edges. Like let's say there is a node 0 that is connected to node 1 and node 2. So we will make an entry in the dictionary with node 0, and we will to make sense of data to represent that 0 is connected to node 1 and 2 and not connected to 3 and rest of the nodes in the graph. What we will do is we will create a list, like the in the dictionary we will have the vertex as 0, and the corresponding value for the for that vertex 0 in the map or dictionary will be a list that will contain vertex 1 and vertex 2 only. So that is how we are trying to achieve the structure to or the that is how we are trying to keep data so that the vertices and the edges on the graph make sense, right? So let's start with the basics. So for the graph data structure, we want a function by the name add vertex, say, let's say. So for this function, the user will pass like graph.add vertex, the vertex number, vertex. So what we want to do is we want that vertex to be added to the graph, right? So what we will do is we will add that vertex as a value to the dictionary, and corresponding to it, uh, we will keep the value as an empty list. That is, we have the vertex added to the graph, but there are no edges connecting to this vertex as of now because we have just added the vertex, right? Now we also want to add edges to those vertices, right? So for that, we will create a function add edge, and the arguments that we will pass is two vertices. So vertex 1 and vertex 2. We want to connect vertex 1 and vertex 2. So here, are we dealing with directed graph or undirected graph? So let's code for undirected graphs, right? So vertex 1 is connected to vertex 2 and vertex 2 is connected to vertex 1. That is what undirected graph is. So what we will do is in the adjacency list of vertex 1, we will uh, I'll access vertex 1 on the adjacency list dictionary, and I will equate, or better, I will append, right? It is a list, empty list, or some list. It is a list. So I'll append vertex 2 to that list. So vertex 1 is now connected to vertex 2. I'll do the same for vertex 2. So in the adjacency list, I'll access vertex 2, and then to the corresponding list, or I will append vertex 1. Now let's also add another function by the name, let's say remove edge. So its function will be, as you guessed it, to remove the edge, that is break the edge between two vertices. So the arguments will be two vertices, again vertex 1 and vertex 2. And this time the operation will be quite similar, but just instead of appending, we are going to remove it from the dictionary adjacency list. So I'm going to access the vertex 1 on the adjacency list and remove vertex 2. I'll do the same for vertex 2 as well. So I'll remove vertex 1 here. So what else can this graph has? So let's add another function. Let's say remove vertex. So what it will do is remove the vertex from the graph. And this one is going to be a little tricky. The argument will be the vertex that we want to remove from the graph. So let's understand the problem that we are going to face is, let's say we have a vertex 0 connected to vertex 1 and vertex 2, and we want to remove vertex 0. So we cannot just simply remove vertex 0 from the adjacency list. In fact, we need to first go to adjacency list vertex 0 and access the corresponding list set of list, and it will have vertices 1 and vertex 1 and vertex 2 added to the list. And then we need to go to that vertex 1 and remove vertex 0 from the corresponding list of vertex 1, because vertex 0 is connected to vertex 1, then vertex 1 is also connected to vertex 0, and 0 is connected to vertex 2, 2 is also connected to 0. So basically what we need to do is we need to first remove the vertex 0 from the connection of 1 and 2, and then we have to remove 0 from the adjacency list altogether. So that is what now we are going to see by programming it. So as we discussed, we need to first iterate over the list of all the vertices, or all the vertices that are connected to the vertex. So that is nothing but self.adjacency list vertex that will return us a list of all the vertices that vertex is connected to. Then I'm going to iterate over the adjacency list of each of this vertex in that list, and over there I'm going to remove the vertex from that self.adjacency list element, right? So that is what I'm going to do. I'm going to remove vertex from all the connected all the vertices that are connected to vertex, and at the last I also want to remove the vertex from the self.adjacency list altogether as well. So this will do that. So with that, we are done. We have the data structure for graph ready, pretty straightforward. We just have to manipulate the dictionary, which contains vertices and the corresponding list of vertices to which it is connected. So that was it. I hope you understood the concept. Thank you for watching the video. And next up, we are going to look at the DFS and BFS traversal.